welcome to a review on solving systems of equations. First of all, if we go with the graphing, remember you got to get both equations in the y equals form. That's the key. Put it in the y equals form, step one. If they're not, you got to move stuff over and undo and do all your algebra. Step two, then, put them in the calculator under y equals. And step three, basically see where they hit. You might see it on the table, you might just be able to read it right on a graph, or if you need to, you got to hit a second trace, that's your calc button. Choice 5 for intersection. Get the spider close to the intersection, hit enter, 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 and you will be all set. It will give you at the bottom of the screen the x and the y coordinate on the calculator. Next method, of course, is substitution. That is not necessarily all yours, but if you get one variable is already alone, or you want to get one by itself, like x equals the other stuff or y equals the other stuff, substitution is a great method. You then take that entire equation and you replace it with the letter in the other equation, the other expression, and you set and solve. You'll figure out the one letter. Don't forget to go back and figure out the other after you get one answer solved. Throw it back into either of the original, probably the one is the best, that you just replaced, and you'll figure out both pieces. Our favorite is elimination. When you got elimination, the equations should be lined up over each other. That includes the equal sign. So x is over x's, y is over y's, equals over equals, number on the other side over number. And then you have to either add, subtract, multiply, any of those methods going through there. Right now I'm talking about just in this case, just setting it up so that one falls out, one variable adds under the other. And you're going to see that when we go over some problems. Or you can subtract sometimes, but we like to talk about it as adding. If you want the multiplying or the subtracting, a lot of times we multiply both sides by a -1, and that will be the same thing as subtracting. Or we multiply one line, here's where you go. So multiplication by elimination is the other part of elimination. Equations, once again, lined up the same way. And you have to come up with a coefficient to run. Or, don't forget, a lot of us talk about it, and don't forget the crisscross method. So crisscross. Well, we'll call it crisscross. That's when we got something like 2x plus blah, 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 and 3x blah, 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 and you take the 2 or the 3 and bring it up here, and you take the 2 and you bring it down here, and then make one of them negative if they're both the same size. That's the crisscross method. But that's just elimination by multiplication. So those are your four: graphing, solution, elimination by adding or subtracting, and elimination by multiplication. All right, and if they tell you algebraically, you must use one of these three here, but don't forget, you can always check using your calculator. Make sure you got time on your exam. Check to get it right, all right? That is a quick review of the system. Obviously, we've got to put it in place by showing you some equations, so we will show that to you in class tomorrow as we go over the different pieces, all right? Have a good Next, we're talking about how to solve a system of inequalities. Well, basically, that's the same thing we just did, okay? In order to solve a system of inequalities, you got a couple different choices once again. Most of you guys want to get it set for y equals. If you get that, we then turn around and we'll throw it like it's like a linear equation. Throw it in the graphing calculator. The big key on this stuff here is, like it says, is treat the So if you get an inequality, once again, if you got a less than symbol or a greater than symbol, okay, once again, that is going to be a dashed line when you graph it. The rest of it's just like throwing it in the equation. If you have a less than or equal to, greater than or equal to, so if you have the equal to bar, it will be solid. Then, less than or equal to, we shade below. And if you have a greater than or equal to, we shade above. Those are the biggest key pieces with inequalities you got to make sure you do that are different from just linear equations. And it says all that right in here about solid versus dash lines, and then the inequality sign, whether you shade above or below, all that good stuff in here. And that's all you do, and you do the same thing for the next equations. And the big thing is you do a big super solution. So, as you can tell right here, nothing's shaded, so that has no solution for either line. This part right here is only a shaded one for this line right here. It's above that. It includes all that stuff, includes there. This piece over here is just for this line as well as this stuff. So our big super solution is right here. Sometimes they make you do a big super solution. Sometimes they ask you to name a point in there. Sometimes they also ask you just to, if a certain point is in the solution or not. So you got to be ready for that. So that's reviewing solving systems of inequalities. How to solve systems of quadratics, or a quadratic and a line or whatever. It could be two quadratics, two quadratic line. Once again, make sure they're both in y equals. Enter that x squared equation. That's if you got an x squared equation, you know it's going to be a quadratic under y equals. It's going to have curved, all that stuff. Make sure you look for the points. You need the vertex. You need to find out where is the middle. Okay? I like to look at the graph itself. A lot of you guys like to look at the patterns in the xy table. Okay? Or if you remember, if you got an xy table, something like that, and whatever it is, they start matching up like this until you find the middle right here. And this middle is called your vertex. Okay, remember that, your turning point, your vertex. So you definitely want to give us an equation. You can't just graph this thing. Give us a table, and the vertex should be in the middle of the table, and then these things match up going on the outside, all right? Then if they ask you to graph that, so you graph that like they've got up here. So we take a look right up here. You got a U shape, and then you graph a line that goes with it. If you get a case like this, as it says right here, there is no solution. Okay, it never hits, the line never hits the parabola and never will, so there's no solution. Here it just brushes, so there's one. And this is the typical, it goes through and hits a 2 point. So we actually have two solutions that would come out, and you could name those two, okay? You could have two parabolas graph. We might have one like this, and maybe they have another one that comes up like this and goes like that, and I get two solutions there. Or a parabola and whatever else. We've seen it all. They could do a parabola with a square root equation, and you could have a couple solutions, okay? So there's all kinds of stuff that they could throw at you. You never know what it is. But the bottom line is, once again, the biggest key is solve, make sure to get in y equals, throw it in the graphing calculator, get it on the graph, see where things cross out, okay? In turn, that's all there is to it. It's an easy one. We love to see those on the exams. Finally, the last part is how to solve system word problems. A little more challenge. A lot of you guys get afraid of them right away, but it's not a big deal. First of all, there should be two things they're talking about. They're called the variables. You're going to write two let statements. Then from the let statement, so you know what x and y are equal to, or L for length and W for width, or C for cost and P for something else, whatever it happens to be. You write the two equations, and then you solve them by one of the methods we just talked about. If they don't tell you how, you could graph them, you could do elimination, you could do substitution, whatever turns out to be easiest. All right? And then make sure you go back and read the whole question again. Okay? Make sure you answer all the pieces. So in this case here, we've got two small pitchers and one large pitcher can hold 8 cups of water. As soon as I hear that right away in my let statements, they got right here, let x be the small pitcher, y be the large pitcher. You could have used S and L if you wanted to. It's your choice unless they tell you what letters you got to use. One large pitcher minus one small pitcher constitutes 2 cups of water. So then all you do is translate it. It was pretty easy. 2 small, so that's 2x, and add up 1 large plus 1 y. You can hold 8 cups of water. The other one is 1 large, y, minus the small pitcher, minus x, equals 2 cups of water. And now you got to go and solve it. So we've written the let statements, we translated and made the equations. That's about the easiest they come. And now you got to solve them. So if you take a look over here, one method they showed you, they lined them up just like this. They turned around and subtracted. We might multiply the second line by a -1, change all those signs. But if you do the subtraction, 2x minus an x, you're down to, it's 2x minus a negative x, because we rewrote the minus x on the left side. Rewrote it so the x is lined up and the y is lined up. You end up, when you do a minus of a minus, you come plus, so that's 3x. y minus y is gone, and 8 minus 2 is 6. Real quick, x, if you do it, divide by 3, x is 2, so there's 2 small pictures. Plug the 2 back into either one of these. I would put it right here, so y minus 2 is 2. So you turn around and add the 2 to the other side like they did right here, and you get 4 for the big pictures. Okay, pretty straightforward. The biggest keys are this right here. Okay, identify what your variables are going to be, write the 2 let statements, write the 2 equations, and then use one of the methods we've talked about to solve. All right, so that's a lot in solving equations, but it's a big piece of our year here this year. So you definitely want to make sure you pay attention to this and probably watch this again video before your exam, all right? Have a good one. We will see you in class tomorrow that will deal with all these pieces.